6.2 angles in standard position and arc length. So let's think about a circle. So if we have a circle, the circumference is 2 times pi times the radius. That's how we find it, or pi times the diameter. So if I have a 360-degree angle, that means that I'm going all the way around. So my circumference would equal the arc length. So that arc would be 2 times pi times r. If I was doing 180, it would only be half of that circle. So if I think about it, it's a half of 2 times pi times r. If I was doing 90 degrees, it would be a quarter of 2 times pi times r. And if I was doing negative 90, it would not be any different. It's still the same chunk of the graph. It's still a quarter of 2 times pi times r. So to figure out this first fraction right here, the way that we find it is we think of it as how much out of 360. So 180 out of 360 makes it a half. 90 out of 360 makes it a quarter. You might be inclined to say that this is negative, but we do not ever have a negative distance or length, so it's not negative. So it makes no difference if it's positive or negative. Okay, so that is our formula. So we're going to take whatever our angle is, divide it by 360, and times it by the circumference, times r. So for this one, we have 80 divided by 360 times 2 times pi times 4. And then we would just simplify. So 2 times 4 times 80 is 640 pi over 360. And you can simplify it, or honestly you could keep it like that, but it would be 16 pi over 9. If you have an ABC button on your calculator, it'll simplify that for you. Alright, next one I would have 200 divided by 360 times 2 times pi times 3. So 2 times pi times 3 is 1200. So we have 1200 pi over 360. This simplifies to be 10 pi over 3. And the last one, it doesn't matter that it's a negative. We don't care about negatives in this. So 135 over 360 times 2 times pi times 2. Type this into my calculator. I would get 540 pi over 360. This simplifies to be 3 pi over 2. So arc length is very simple. Okay, a tire has a diameter of 60 centimeters. What horizontal distance is traveled when it rotates the following degrees? This is exactly what we just did. As a tire is rolling, it's going to unroll this distance onto the ground. And then it's going to roll again. And it's just the distance around the tire. So we're going to go 1080 over 360 times 2 times pi times 30. And because we're dealing with a word problem here, we can just type this into our calculator. It says to the nearest millimeter, so 1 decimal place, you should get 565.5 centimeters. So I want you to pause the video and I want you to fill in the rest of these examples. So you should have got 3000 over 360 times 2 times pi times 30. By the way, in case you were wondering why I used 30 instead of 60, this is a diameter of 60, so my radius is 30. Be careful with that. I skipped saying that. So you should have got 1,570.8. And the last one, 685 over 360 times 2 pi 30. And you should get 358.7 centimeters. And that's how you do arc length. It's very simple, but I guarantee you probably forget about how to do this. Everyone else seems to. I don't know why. Even me. Alright. That's all I have. You're all doing so amazing. I'm very proud of you. Okay, bye.